Hi everyone, welcome back to this channel. This video I'm going to show you the test result that I have obtained over 2 days using FieldFox. Just a simple measurements at the span of 180 meg at 903 megahertz, just to check is there any interference going on for the span of 36 hours. What you're seeing here is the sample code that I developed on Python that create files, stop frequency, and then calculate out the number of points. And this is where I set trace to, or the backend mode, to max hold, so that we be able to capture whatever signal that appears. So as you can see here, I actually let the signal settle down for 20 seconds, then I capture the signal and put in a CSV format. So this is how it looks like in the FieldFox. So what I did was just set up two traces. So I go to trace and turn on trace 1. Trace 1 is the yellow one that is up and running, and trace 2 is to max hold. I let it settle down for 20 seconds, let the signal appear, and I'm saving trace 2 as a data for post-processing later. And there are some signal activities here appear randomly, but it's not always there. So this might be one of the out-of-band interference signal. So bear in mind, what we can do here with the max hold is to find out the out-of-band interference. What do I mean by that? If you have a signal within this LTE signal, and if the interference is right in the band of it, you won't be able to see it in spectrum analyzer mode. And if you want to find the interference within that band, you probably need RTSA, the real-time spectrum analysis. So we don't cover that today, so I'll just let this run for 36 hours, close to 10,000 traces, and then we do some post-processing after this. So after obtaining the data, we want to do some post-processing to the data so that we can see, visualize it, what we are seeing, any interference around that area of frequency interest. So as you can see, this is just some part of the code. I won't show you much here because there's still a lot of things to tidy up, but I can show you the results of it. Let's run. So this is how it looks like after I plot out 36 hours of data. The x-axis is the frequency range, the stop frequency, and the y-axis is the time when the data was captured. And you can do wonders with Python. One of it is to have these xy coordinate things, and as you can see on the bottom right here, so as I point out here, my x is at 962 megahertz and my y is happening at the 19th of August at 2:25 p.m. and the power at that point is minus 175.5 dBm. So if I move it here, you can see that power actually changed. And this plot actually showing that part that I'm going through right now. So as you can see that I can just go through on vertical format. It will just update the trace, so you can see there's some interference happening here. Okay. Anyway, let's zoom in so that you can see it better. Let's say I want to look at here, this area. This is something that appear, random name here, and the plot at the bottom right, it's when I click, so it's just stay there, so that I know on the 19th of August at 9:44 p.m. there's some activities happening here between 837.7 meg to 852.2 megahertz. So there's some signal happening during that time. So we can do that over here. So as we can see, essentially this is just a proof of concept to show you that you can use FieldFox to do some measurements over time, and with that you're able to do some post-processing using any script of your preference. Python just happens to be one of it that you can use it. Again, this just to show you by using FieldFox as a receiver, you can just leave it out in the field, do a measurements over time just to find out the baseline and also the interference that you might be dealing with at the area. After collecting all the data, you can save it to the local computer or on the FieldFox. Then you retrieve it, do some post-processing, and you can plot it out and put it into your reports. All right, thanks for watching.